Prof.Bong Keun Yoo is a principal researcher at the Institute for Infocom Research at A*STAR, and his talk titled by the Artificial Intelligence Automatic Speech Recognition. Please welcome him.
All right, thank you.
Good morning, everyone. I will present about artificial intelligence ASR. Next slide. Okay, before presentation, I would introduce myself. I have been working on speech and language technology in the USA, Singapore, and South Korea for over 20 years. Also, I have researched and developed deep learning on ASR for over 9 years. I researched and developed AI ASR on Android platform for English, Mandarin, and Malay. Now I am a principal researcher at A*STAR, and I also delivered English, Mandarin, Malay, Thai, Indonesia, Tamil, and Bengali ASR. 12 technical disclosures and 3 software IPs were accepted at A*STAR. Okay, thank you. And next slide. Okay, the table of content is as follows. Speech processing is the study of speech signals, which is related to natural language processing, machine learning, and signal processing. As we know, ASR converts speech to text. It means ASR gets the sequence of a word which is from the given audio data. It needs acoustic model and language model. This acoustic model is trained on deep learning, and this language model is trained on natural language processing or deep learning. This slide is showing us a software architecture of ASR. It needs an acoustic model, lexicon, and language model before we run a speech decoder. Sorry. Okay. And this acoustic model is built with a speech corpora, and this lexicon model is built with a text corpora. Before we make a lexicon, we need to design a phoneme set first. After we design phoneme set, we will make a lexicon, which is called the pronunciation dictionary. And this lexicon contains pronunciations of each word. Some words are not contained in lexicon. We called out of vocabularies. This slide is about the language model. The language model is the use of various statistical and probabilistic techniques to compute probability of an upcoming word. We use this formula. Can you see my mouse point? Yes. Okay, thank you. And okay, actually, ASR uses engram-based language model. Generally, we use trigram or 5gram. It will be depends on systems. This formula is for estimating bigram probabilities. The probability of the word wi-1 to be followed by wi is the number of occurrences of a probability of a consecutive word wi-1 wi divided by the number of occurrences of word wi-1. This is a simple example. If we want to get the probability 저는 싱가포르에서, first we need to calculate the number of 저는. There are 2. And if we want to get a consecutive word 저는 싱가포르에서, there is only 1. So probability is 0.5. Of course, when we use these probabilities, we need to take a log function. This formula is for estimating trigram probabilities. Okay, sometimes we need to interpolate a language model because we already trained a language model, but we can see a new word, for example, COVID-19. So it is out of vocabulary. So we need to add COVID-19 into lexicon and language model. So we don't need to train a full-size language model again, because it will take a long time. So we will collect some text data that consists of a new word, COVID-19, and then train a language model and interpolate the new language model into existing language model. So we will create a new language model. If we build a new language model, accuracy will be reduced. Okay, this slide is about data augmentation. So there are a few types in this slide. I'd like to introduce speed perturbation and multi-condition data. So when we have the speech data, so sometimes it is small. So if we use this data augmentation, the amount of data will be increased. So we speed up the wave file and speed interface called JNI to communicate Java and C++ libraries. Of course, C++ source code in ASR systems need to compile by NDK build. So this Java is responsible for graphic user interface, getting speech data, displaying output data, and calling JNI functions. This JNI is responsible for calling C++ libraries, sending speech data to ASR, and getting output data from ASR to sending the result to Java. One more important thing, this C++ source code needed to compiled again for Android platform. This ASR systems this ASR system is using a lot of open sources. They also need to compile on NDK build. After I put these systems into Android phone, I updated matrix multiply because it was very huge time. Also, I added a bottleneck layer between last hidden layer and output layer to reduce the response time. When we develop ASR systems, there are a lot of keys. So we need to have a very huge big data, have to have many GPUs to reduce the training time, and we need to know AI algorithm, AI experience, and ASR experience. Okay, thank you.
Thank you, Dr. Yoo. If anyone has a question, please raise your hand, please.
I have a question.
Sure.
So, I mean, it's excellent talk about artificial intelligence. And it is true that now everybody talks about artificial intelligence, multi-user generation, and a lot of people, especially engineers, we want to apply our research with the artificial intelligence. Do you have any advice and comment how can we do that? For example, let me give you an example. I developed diagnostic tools, for example, COVID-19. How can we, using your knowledge of data, artificial intelligence, applying to our biosensor modeling, for example, or diagnostic tool to do that?
Okay. So first you need to study and research standard deep neural network first, because if we don't know standard deep neural network, we cannot design any network. Also, during you are researching and developing any standard deep neural network, you need to collect text data. So only input text data? No. Input data and output data together. Also, you don't need to develop any AI algorithm because there are so many open sources. So you can choose one of them. So if you don't understand the standard deep neural network, you cannot use the open sources. So after understand the standard deep neural network, how can we get the weight and neurons and forward fast phase and backward fast phase, and then test it, and it is okay, and then go to next step to change the network to improve the accuracy. First, we need to change the network, and then also we need to change the number of hidden layer. So increase the hidden layer. Of course, if we increase the hidden layer a lot, there will be overfit. So we need to train model a lot. So we will choose one of them which has good result. Also, the machine is important to train a model. Please purchase GPUs. So if we use multiple GPUs, you can train a model quickly. And then if you get a bad result and drop it and train a model again. So time is very important.
So this is machine learning.
Yes, that's right.
All right, thank you very much.
Okay.
Thank you.
Thank you.